it is with great pleasure that the Center for Online and Continuing Education presents you with this amazing professional development session. We have an exciting panel of guests today, and we'll be looking at STEM labs, learning how to do things of this sort on our own, and some resources for it. And with that, I will pass it over to Dr. Abigail Perkins.
Hello, thank you for joining us this afternoon for STEM Labs with Immersive Online Content, Practitioner Perspectives, and DIY Resources. I am Dr. Abigail Perkins, and this professional development session is brought to you by the Center for Online and Continuing Education. We are the 5 founding members of the Florida Atlantic STEM Research Group for digital laboratory learning. We are an interdisciplinary team.
Hi everyone, my name is Evonne Rezler and I'm the Senior Associate Dean for Undergraduate Studies in the College of Science. I am a chemist by training, so the Department of Chemistry and Biochemistry is my home department in the college, and I'm one of the research leads in this research group, in this research team.
Hi, everybody. I'm Julie Golden-Botti. I'm the Assistant Provost for Online and Continuing Education, and I am the Digital Learning Lead for this group.
Dr. Jennifer Krill. I'm the University School Assistant Professor of Neurophysiology, as well as an Experiential Research Lab Coordinator at FAU High School in the College of Education, and I am the Biology Lead.
Hello again. I am Dr. Abigail Perkins, the Educational Research Lead for this project. I am the Learning Strategist in the Center for Online and Continuing Education.
Hello, I am Dr. Ozlem Yavuz-Petrowski. I am Assistant Lab Director and General Chemistry Labs, and I am working as an instructor in the Chemistry and Biochemistry department.
The QR code in the upper right takes you to our team homepage. Our overarching purpose is to increase agency and empower effective STEM laboratory and technical learning through faculty for students, building and disseminating the evidence base for best practices in digital and virtual laboratory learning. Our roadmap for our project and this presentation is conducting research, collecting data on student learning outcomes. Our team is conducting research in these labs, collecting data and evaluating the efficacy of our IOC approach, Immersive Online Content, IOC for short. We will go through the definition, the goal and applications, whether STEM or in another academic domain, followed by 360-degree virtual reality labs where you get to experience the demos live, see what the students see while hearing and experiencing the practitioner perspectives, the narratives, and what it's like teaching and instructing in these environments, followed by a DIY toolbox. Yes, you too can do immersive online content in your course, whether small in scope or large in scope. And we will conclude with some remarks with a special invitation at the end.
So let's start with what is immersive online content. As we define it in our research group, it's high-level interactive course content or instructional material. It takes course content from passive, like just reading or listening, to active or interactive content. The content is aligned to the course or module objectives. It's relevant to the student learning process. It's relevant to the acquisition of new knowledge and to the assessments, of course. And the concept is to provide authentic engagement with the course content so that the student has the agency or the choice to move through the learning experience in their way. Now I'll pass it over to Dr. Rezler. She's going to tell you about our research questions.
So really, it's the key and common research question of interest that draws us together as the research group that we are. And this question is whether using the IOC approach that Dr. Botti just described in online technical labs such as chemistry and neurophysiology labs, we can then maintain or improve student learning in those courses. That is really the crux of our research. We have additional questions, and they are also focused on whether we can use this IOC approach for training and improve the quality and standardization of TA training. And then, of course, through workshops and talks like this one, we hope that we can facilitate this approach being used by other faculty in both STEM and non-STEM courses to deliver future-proof, so to speak, content to our students. And I know Dr. Krill will be mentioning the upcoming Hurricane Ian, as an example of what we can do with this IOC approach. So I hand it over to her.
Thank you, Evonne. So I wanted to talk a little bit about why I started developing immersive online content and implementing it in laboratories. So I developed a biology lab prior to the pandemic, and faculty perception at that point in time was online labs don't work. And I really feel like this is a perception more of canned labs, so labs that you buy. You don't have any sort of faculty presence. You don't control the content or the way that it's delivered. And so we started to develop this immersive online content to kind of put the student back in the actual laboratory, and then also put the faculty member that's delivering the content in the way that they see fit in the laboratory. So I wanted to go over a couple of the things that you're going to see before we dive into the 360 VR lab. We have our students up here, and students can really, once you develop this immersive content, students can interact with it in different ways that they feel comfortable with. So whether it's a cell phone, or whether it's a VR headset, or whether it's their laptop or computer, students can interact with the content that you have created and developed in a variety of different ways. Oh, you'll also see different icons there where students can click on different things, maybe learn about a different piece of equipment. You're also going to see different guiding cues. So experiments are done in a sequential manner. And so how do you guide students through this 360 realm? You can put guiding cues in there to show students where to go next for the next part of the experiment. You can also embed 2D videos. And so you can deliver your content, maybe an introduction to the experiment, even maybe feedback for students after they answer a question. And you have your probing questions with just-in-time feedback. So this is really an advantage of this online immersive content, because you get to ask every single student in that class at the right moment a question that you want to ask them all. And the student will get feedback. You will get feedback as well as to what is their learning. Are they learning this material? Are they not? So maybe you can adapt your content that you've created. And then the student also gets feedback immediately. Do they understand the content? And so we're going to dive into the lab now. So this is our neurophysiology lab. As you see, we are actually in the laboratory here. And we have, I'll turn up my sound a little bit, but you have your faculty present. You are in the laboratory delivering that content to those students in a way that you see fit. So I'm not going to play this for the whole time for sake of time. But then you have, so hopefully the student watched your entire introduction, and then you can have this probing question with some just-in-time feedback for the student. And then you're going to get this guide cue here to then move on to the next part of the experiment. There's also a play and pause, just in case students need to get up from their computer for a moment. Here you're watching the anesthetization of the earthworm. Students are going to get questions about the proper procedure afterward, just to make sure that they know what is actually going on in the laboratory. And just for sake of time, kind of move on. Now that we've anesthetized our earthworm, it's asking the students questions again, about where we putting these electrodes in to the organism to then set up our animal preparation. What we're going to do later in the laboratory is hook that up to a stimulator and then excite their neurons, and then have the output on a screen over here. And so you can go through, the students are going to then watch the rest of the animal preparation, get some more questions. And I feel like this also not only is very timely, this presentation, merely because of the impending hurricane, but this was really developed during the pandemic too. And so this development of immersive online content for faculty, you can use this for your in-person classes as well to, if the university is shut down, if you have some sort of building renovations where you're not able to hold lab, whether there's another outbreak of COVID and we have to shut down for that, you don't have to shut down your instruction. You can seamlessly continue even your in-person instruction by having these as backups and having the students then go through the actual lab. Yes, they're not inserting the electrodes into the earthworm, so then maybe they're not getting that tactile experience from that, but they have to know how those electrodes are inserted, where are they inserted, why are they inserted in those places. Students also then, as we're moving to the next scene here, students are also going to then see the stimulator. They're going to get a 2D video here, but then this screen also pops up with a 2D video, and students actually get the data files that then they have to download the software for the program to then analyze their own data. So while they're watching the techniques and they're watching the acquisition of that data, then they actually work with the actual data from the laboratory to then write their laboratory reports. So this not only future proofs, but I'll just go to this, give you guys something to watch here. So we have an additional video about what we're doing. But this also not only future proofs, but it also increases access for students. So our laboratory or our school is not a typical school where students live on campus and just take classes and don't work. We have a lot of commuters. Our students have families or they work full time. And so by providing this online class as well, students are able to access this course content. If they are not available to attend in person, they can still attend online and get the content and the knowledge and the technical skills as well from this. Another advantage I would say as well is for TA training. So whenever you get new TAs, maybe you have 25 TAs, depending upon what your lab is, how are you going to know what content those TAs are delivering? And so by using this as TA training as well, TAs know the content, they know the steps in the laboratory, they know the outcomes for the laboratory, they know the questions to ask and when to ask students and what those answers are, so that you can have seamless instruction across TAs for your laboratories as well. So without further ado, I'm going to hand it over to Dr. Yavuz-Petrowski, our chemistry lead. And I'm going to read a quote from one of her students that went through the immersive online content in her course and what they felt and thought of it. So the students say the labs not only teach them what tools and instruments to use, but also shows them how to apply the skills. Most of the students feel they're in the actual laboratory when they are completing the experiments in our 360-degree labs.
Hello, everyone. So I am going to talk about why I started developing these 360 labs. My first to facilitate the student learning experience and improve our teaching methods. And later it became our research project. Now we are analyzing every step of this development. And today I will share with you one of the first developed online lab that V60 lab I developed. Simulation in this first 360 lab that I have developed start with the you just click in the arrow and enter the lab, and simulation practically guides you what to do in the lab. And in this case, there is an instruction is given, says look around, and by clicking on the screen and dragging the mouse around. And if you can also use the VR, and if you are using the VR, you can just move your head around. So I will just give you a quick tour on of our general chemistry labs at the chemistry and biochemistry. So students can explore the lab anytime during between the experiments. So this particular experiment and simulation also goes you how many questions in this particular experiment. So since this is the first basic simulation 360 that we have developed, most of them starts with the introductory videos, as Dr. Krill mentioned. So this one starts with the probing questions. So it's just asking a questions, and student can answer the uh, questions and gets the immediate feedback. And then simulation guides you to watch the video, explanatory video about the outcome of that questions. And there are more further questions about the simulations or about the technique that is given for the students. Example in here that students expect to know, or with the given instructions, of course, further in their modules is asking what is the solution in the bread. So you can student just give an answer and feedback again if the question is correct in this case. And later on, simulation starts with the 360 demonstration and further questions. So, and also questions that support their understanding, and also questions that uh, analyzes their outcome of to experiments, such as in here, what is the process called? So basically, it is a titration experiment. So now I am going to continue with the presentation in here. And in these 360 videos, and also students can collect and analyze data. So as we mentioned, as you have seen, the 360s are interactive, and there are questions, engagement questions, and introductory videos in the simulation. So in this particular simulation, students has to observe the experiment and perform the experiment also at the same time with the amount of the regions is given for that particular experiment. So students are performing the experiment and guided to perform the experiment by using these regions and outcome of the experiment. So student also can collect data. And 360 students doesn't only perform the experiment, or also they learn the techniques, such as in this case, they are learning how to use the pipette, or sometimes student uses how to read the graduated cylinder, or how to make the measurements in the specific instrument or in the specific experiment. And students also can do data collection. So they have to complete the lab report at the end of the simulations when during that week when they perform the experiment. So in this particular slide, students has a table that they can do the observation, and they can record the observations. And the probing questions, the specific probing questions guide them what type of observations they are gonna do. Basically, it directs them to do observations for particles well placed in here. And sometimes the observations are just visual, sometimes numerical values. So students can also collect the numerical value for through the 360 videos. And what has three are digital content include. So we are talking about more 360 videos, but IO content, it is not just only 360. We have each module for one experiment that we have approximately 3-4 recorded videos for that individual experiment. So it starts with the introduction module. It is recorded whiteboard presentations or lightboard. Here is the example, one of my lightboard presentation for students to watch it before they perform the experiment in the 360. Also, simulation, the IA content includes PowerPoints, recorded PowerPoints that go over the background information and calculations for the students. And IA content and also contains the extra and low stack activities such as FAD simulations, such as uh, screen experiment, chem collectives, and anything that support the presented experiment. So students go and do extracurricular activities. Some of them is graded, some of them are not graded activities. And one thing that I want to mention, all those 360 activities that students perform, they have an unlimited attempt. So student can attend anytime, any day, and multiple times, as many as they like to complete the assignment. So they have that freedom. And now I will hand over to Abigail.
Hello. Thank you, Dr. Ozlem Yavuz-Petrowski. And I'm a fan of the Lightboard and all of IOC. The DIY goal, immersive online content approach, whether you have an innovation hub or are interested in having little pieces of IOC, you can do it yourself. DIY, in essence, is future proofing in repeated cycles. There's TI training. And as Dr. Ozlem Yavuz-Petrowski mentioned, this is filled with opportunities to integrate retrieval practice with low stakes, integrating into the course itself with low stakes, rereading over time, spacing content. And here we have one of our overarching goals of the DIY approach in 6 steps. Step 1, pick your space. Simple as a phone. Pick your space. I'm not recording. Pick your space. Record. Press the record button. Depending on the software chosen, add quizzes, hotspots, whatever you wish. Save. Post online. Students interact. Immersive online content spans domain beyond STEM. Google Arts and Culture is one example, filled with museum VR tours and AR examples. There are also examples of orchestral audio 360 experiences beyond just the visual sensory systems. The Center for Online and Continuing Education Professional Development sessions are also available on our YouTube channel. And here are a few curated examples that may help you get started. And I would also like to take the opportunity to include an example of AR. AR stands for augmented reality. In Google, there are other examples beyond museums and orchestral experiences, such as an AR forensic laboratory experience. So really, the sky is the limit. There's history examples, architecture, economics. And yes, these are links which will be provided to attendees after the session. How do you go about starting? Here are some cameras and production software that we have here at the Center for Online and Continuing Education Innovation Hub. This is just a snapshot of top of the end. You don't necessarily need all of these. Most cell phones have 360s nowadays. Come with programs where this all can be done on your cell phone. But here's an example of one snapshot of profile. Cameras, newer smartphones, GoPro, $399. That continues to decrease, and you can always find refurbished ones for much cheaper. Insta360 is another option. Insta360 Pro. The packages, depending, the price depends on what you want and what your needs are, which all root back to your learning objectives. Also, these companies want to sell you the software, so you can always, there's typically always an option to negotiate an educational discount. Production software. The Innovation Hub uses Scenario VR, which is a production software that prides itself on being a very user-friendly interface requiring no editing experience. It typically is $1,599 a year. Again, there are discounts to pursue, educational discounts and group discounts. Articulate 360 Suite includes a Storyline 360 app, Rise 360 app, plus add-ons. The full suite itself is $499 a year. If you only want one of these options, then that price will vary to much lower. There are also Adobe options that change, the bundles change. And this again all roots back to your learning objectives. If you would prefer to just contact a company yourself instead of going through and finding which is which, those companies are more than happy to help you. Here are a few curated video links and documents and forums to help you if you wish to explore on your own before reaching out to anyone. For Scenario VR, there are a few quick links and a document that's a getting started guide. Also, Articulate. Do you want Storyline? Do you want Rise? And there's a quick overview. And also, yes, this can be embedded into Canvas if you wish to go that avenue. Audio and lighting. Again, lights over your head, or outside, or on your cell phone. So those all really do work. If you want the full creme de la creme Innovation Hub, we have Manfrotto VR Medium Carbon Fiber Extension Boom. That's something that I might need right now. It's a piece of foam over a microphone. We have different microphones, audio recorders, wireless mics that you can put on your lapel and have hidden in the background if you want to be out and about in the field. There are different lightings with tripods and stabilization depending on what you would like to do. Are you interviewing someone? So these are all various options to consider. Again, higher and what we have here at the Innovation Hub, you don't necessarily need that. It's all going to be done really on a basic laptop, smartphone, and even a lot of tablets. Resources. Would you like to get started, whether small scale or large scale? Funding is available. A little bit of research goes a long way. There are lots of DOE, Department of Education grants continually coming out. Municipal prizes, depending on your location, industry grants or sponsorships. Reach out to one of your local industries, one of your local companies. Perhaps they are interested in having some sort of charitable or a socially responsible interaction in which they would like to engage. There's foundation awards and also university level grants and funding. What I recommend that has been helpful is just signing yourself up for a listserv here and there. And after a while, those listservs start to provide a lot of information that can then steer you in, oh, this is a better listserv than this listserv. And before you know it, there are lots of funding opportunities available. And it seems to be a matter of figuring out how to then clone yourself to apply for all of them. So when there's a will, there is a way. And what you see on your screen right now is one avenue to start that way. we have our concluding remarks. I am cognizant that it is 12:46, so let me quickly please request your time and consideration in sharing your perspective and your input through our anonymous feedback survey. Here is a QR code and a link. It's very short, 1 to 4 minutes max. We would very much appreciate knowing how we could better help you and how we can improve our work and our presentations. Again, this link and the QR code will be provided to the attendees here after the presentation. And we also have a special invitation to the Immersive Online Content Community of Practice. And Dr. Crow, would you like to mention anything about our Immersive Online Content Community of Practice?
Sure. So in our community of practice, we invite you to you can come in, we post resources there. You can share resources that you find as well. More and more, there's a wealth of online and, 360 kind of experiences that come about. And so we'd really appreciate, and others in the community of practice would appreciate just introducing yourself, and then you can look through the materials that we've collated already, and then you can add your own as well.
Yes, thank you. It's an opportunity to have a space for whatever you would like. There are some questions that are already posted in there, issues that some have run into. Whenever we present, we always invite our participants, whether at conferences or a session such as this, we always invite our attendees to join our immersive online content community of practice. It's filled with resources and even more curated content than what you've seen here. And we do have some time left for question and answers. The only remaining slides that we have are our references and a thank you page. So at this moment, I'm going to ask Dr. Judy Summers if there are any questions that we have received from our attendees for any of us.
No, you have completely captivated this audience with everything. Our biggest request was to have access to the information, and we definitely will be doing that. Again, we will give everyone the opportunity to post a question or to ask to have your mic unmuted so that you can ask them to any of us.
I was also going to say, you don't have to make an entire lab at first to implement immersive online content in your classes or embed it into Canvas. You can, I guess, engage in immersive online content as deeply or as shallowly as you would want to. You could even, just have part of a module is going to a museum and looking at some paintings or something like that as part of your art appreciation class, and actually having them go to the museum and navigate around and look at pictures or paintings, I guess I should say. So you can just implement smaller things too to kind of engage your students in additional exercises outside of class too.
Hi, good afternoon. Just thinking practical purposes, once you get the hang of things, how long does it take you to set up a lab session, a lab experiment? Once you start, if you want to set up a whole lab course, for a full semester, each lab session, how long does it take you to set it up? Depending, I understand, but let's say by now you're fairly confident in using the software, etc. Is that, how far ahead, if I wanted to do something like this, how far ahead should I start, working on this and, so that I can have everything on time?
I can answer that from the perspective of the Center for Online and Continuing Education. If it's for an online course, our group would help you do this. We would give you the benefit of our photographers and editors and all of that. And we ask that at least a semester beforehand you would do this. You would work the semester before that to launch it, and the next time 2 semesters beforehand would be
Yeah.
even better.
Even better. Yeah, I was just thinking that, our labs here are in person at Davie. We have general macro labs and AMP labs. And even though the course is in person, but I see this as a tool to perhaps reinforce concepts. Also, and also for the students to perhaps see ahead of time the experiment that they're going to be doing in class. Because even though you ask them to read the manual and, uh, have a notebook where they should sort of, put a summary of what they're supposed to do, at least for micro. But I think, a visual thing is also very, these days, they just do better. And that's one of the things that I was thinking about for the labs, that even if it's not an online class, but it would certainly be very useful for either an additional assignment or for as a pre-lab. And like you mentioned, I think it was Dr. Rezler, I don't know who, about for training TAs as well.
It's a great idea. Flipped classroom, hybrid classroom, those are all great uses for this. And if you're on the Davie campus, I don't know if you've been by our Innovation Hub,
Yes.
which is what's behind me here, but that's where we
Absolutely.
do that
Yeah.
work. Yeah. Okay, good.
Mhm.
I'm asking my research colleagues, Jennifer and Ozlem, how have you used, or how do you intend on using IOC approach to involve teaching assistants?
Well, I would say my class is pretty niche. So the TA number one has to have at least some sort of neuroscience background, but then learning the techniques or learning even what, the content is or what different things, how to even explain something, right? And how to explain a concept. I think that, when we all start out teaching, we don't know how to teach or how to explain things. And so I think just going through the process of going through the lab, they're able to get the explanation with the way that you would have presented it to the student, and then be able to emulate that, maybe put it into their own words, but be able to at least then address any sort of content and know what are the results supposed to look like. You're depending upon what lab and the students, and if they've made a mistake, what are the results actually supposed to look like the first time that they do this laboratory. And so that helps to support them in effectively teaching the course and to delivering the content to your students in an effective way.
Yes, Dr. Ozlem.
I currently use not for all the TA training, but a couple FAU TAs that I feel like they are lacking in behind the theory, or they are lacking in the presentation. So I actually give these courses to monitor them, that they can go and then practice a little bit, watch the videos, and then they can feel more comfortable to represent the material better for the in-person learning. So using these online sources and online labs, actually, that is gonna help them to be better TA in the in-person lab. That's what I'm doing right now for FAU TAs.
Yeah, and I wanted to add to that. Sometimes you don't know where the deficits for the teaching assistants are, what they don't know. And this allows you to standardize that knowledge for your TAs. And I've taught large lab classes, so to speak, multi-section lab classes, and that has always been an issue, not knowing what your TAs don't know. But if you require them to, take part in an immersive online content module to get that training, you know that they're all getting a certain standard, a certain high quality standard of knowledge base that they can then, when they're teaching students in person, they can then, draw upon, rather than kind of going in there blind, some of them, and not being able to express that to you as the faculty leading them.
I was also going to add, and I forgot to say this before, but with increased attendance too, you only have so many spots in your laboratories. You can't really start going from, you start to change labs from 8 a.m. at night, and then they're running till 8 p.m. But there's only just so much of a capacity. And so by developing these online courses, you not only can supplement your in-person, but then also you don't have to just meet that capacity of what the physical room is. And with growing enrollment year after year after year, this could be a solution for specific laboratories too, where you can put those and transition those students online and do it effectively, where you're not concerned about, are they really learning the material or not?
Thank you, Dr. Everyone, Dr. Rezler, Botti, Krill, and Yavuz-Petrowski. With our remaining minute and then other minute to conclude, where I will turn it back to Dr. Summers, I'm going to quickly move to our reference pages. And a quick thank you, just so you have a preview here. Hopefully you all are still seeing my screen. We have the references. Again, these will be sent out. I know this is a lot to see in a small screen. And then thank you very much for attending. Stay up to date with us at our webpage, at our home webpage. And with that, thank you very much for your time. Thank you to my dear colleagues. And Dr. Judy Summers, I hand it back over to you.
What a pleasure this has been today. I appreciate the intensity and the dedication of each one of you and your willingness to share your journey and your lessons learned. So we do appreciate that. And for all of you who have joined us today, we will definitely be sending all this information out to you. Thank you so much for being with us today.